This is the Mechanics Homework Booklet, question 22. A tennis player serves a ball from a height of 2.51 metres at 18 metres per second in a horizontal direction. The ball just clears the net, which is a metre high, and we can assume that air resistance is negligible. The diagram shows the path taken by the ball. Part A. You are asked to show that the ball takes approximately 0.6 seconds to reach the net after being served. So that is the time between these 2 points on the trajectory of the ball. Now be careful. This question says show that. It is good to adopt the policy here when a show that question is written to actually work as much as you can with the algebra using symbols and to leave the substitution until last. We're finding in some mark schemes that is a more secure way of getting all the marks shown. So to find the time taken for the ball to reach the net, we're going to consider vertical motion of the ball. Now looking at that, we want to find the distance fallen by the ball vertically from when it's served until when it is level with the net. That distance is 1.51, but this is a show that question, so I think it's well worth showing the subtraction. The mark scheme allocated a method mark at this point, which implies that if this isn't shown clearly, you can obtain no further marks later on in the question, even though you might do everything correct. So a distance of 1.51 metres fallen, an initial vertical velocity that is 0, an unknown final velocity, and the acceleration due to gravity. We want to know the time for the fall, and we don't know v, so we can select the equation s equals ut plus a half at squared. With u equals 0, this simplifies nicely to s equals a half at squared. Because this is a show that question, it's worth at this point rearranging that to say t squared equals 2s divided by a. And then finally t will be the square root of 2s divided by a. Once again, a method mark was allocated at this point. Finally, careful substitution leads to an answer of 0.55 seconds, which is consistent with the value of 0.6 that you were asked to show. Next, you are asked to calculate the vertical component of the velocity of the ball as it passes over the net. For this, you're using the same list of data as we have previously stated here. It's the same part of the journey that we're analysing. So looking at the vertical motion, I've chosen to not use the time value. We were given u, v, a and s, and so that's a convenient equation to use and no chance of repeating an error had one been made. So substitution into that, with u equals 0, we just have v squared equals 2as, and we take the square root of that value to give our final answer for the vertical component. Glancing back at the data we were given, we did have 3 significant figures for our distance and for the acceleration, so it makes sense to preserve 3 significant figures in our final answer at this point. Lastly, you're asked to calculate the overall velocity of the ball as it passes over the net. There is quite an important clue here with the phrase overall velocity. So they're being quite helpful, steering you to think carefully what they might mean by velocity and why it might be an overall one. The implication is you're going to need to consider both the horizontal and the vertical components and put them together. So the horizontal component of the velocity was 18 meters per second. That was given in the original part of the question, and we have just worked out the vertical component of the velocity when it passes over the net, and that was 5.44 meters per second. Looking at this triangle, you can see that use of Pythagoras will enable you to find the magnitude of the overall velocity. Finally, when asked for a velocity, you should also state a direction. You're clearly led to do that in this particular question, so we want to know the angle that this resultant velocity makes with the horizontal. So in this triangle, tan theta equals 5.44 divided by 18, and that leads us to a value of 16.8 degrees to the horizontal.